morning. Okay, you don't have to say that. Welcome to Compass for Next Generation ICT, messages from RIEC Nationwide Cooperative Research Project. I thank all of you joining us. I thank particularly the people with a long trip from abroad. I'm just want to ask you, my voice is okay? I'm not perfect condition because of the cold, but I tried my best to recover by now, and it seems working now. Okay, this is a meeting, annual meeting for the cooperative research projects. And my job here today is to introduce our research institute. That is a Research Institute of Electrical Communication, RIEC in short, and Cooperative Research Project, CRP. Content is then. In addition to the two I described, I want to describe a bit about the actual project which I have been involved in. That is about the color lexicon. Cultural and individual differences in color lexicon. So, introduction to RIEC. Our institute, RIEC, belongs to Tohoku University, and Tohoku University was established 1907 as the third imperial university in Japan. That means the third oldest national university in Japan. This slide shows the old pictures from old days. And now we have about 18,000 students and over 3,000 faculty members. This slide is a bit busy and small letters, but you don't have to read, of course. Just show the organization of Tohoku universities. There are about 30 faculties, schools, and institutes, and we are one of 6 institutes of Tohoku universities. This slide mentions about the mission of our institute. In short, we usually describe our mission as to creating the communication technology that enrich humanity. RIEC has a long tradition of research in the field of high density, high speed, high level information and communications. But now, with this in mind, trying to create technology that enrich human communication in the society. So that is our mission, and to reach the mission, we have this kind of organization in our institute. There are 4 divisions. That is for the basic research, meaning the long-term scope. There are 4 information division, broadband engineering, human information systems and software divisions. So all the members belong to either of one of the division, 4 divisions. And also we have 3 research facilities. 2 are laboratories. That is so-called midterm scope facilities. One is a brain-wear system. The other is nanoelectronics and spintronics. People who have a particular project for the midterm scope belong to these laboratories. Brain system laboratory work on the new type of the LSI based on the brain-like systems. And laboratories for nanoelectronics and spintronics are creating the devices for the based on the nano spin technologies for future ICT. The third one is a bit different, and even for shorter scope, 5 years, they work on a project with industries to achieve the goal within a shorter period of time. There are also several organizations where our members are involved as core members. Okay, this slide shows brief history of our institute. RIEC was established 1935, and around that age, there are great inventions in Tohoku University in the field of ICT. One is herringbone type antenna invented by Professor Yani and Udas. So Yani Uda antenna. One is a split node magnetrons invented by Professor Okabe. And another one is AC bias magnet recorders. They are great in terms of they have been used a long time and also worldwide. Following days, there are also a great invention in our institute. Three elements of telecommunication and static induction transistors by Professor Nishizawa. Also the perpendicular magnetic recording system by Professor Iwasaki. Both of them received Order of Cultural Merit in Japan, and both of them are also the former director of our institute. Professor Nishizawa unfortunately passed away last year, and many people came to express their regret in their memorial service. They are not only the people from university, Professor Nishizawa was concerned, but also students from the Sendai and Miyagi prefectures. Okay. I'm not sure about time. This slide shows some achievements or activities of 4 divisions. Because I don't have much time here, and also you can find topics or projects related to the end in the following sessions, also in the poster sessions. So I just name one word summary of one of them. This is about new technologies for the high density recording. This is a new technology for the ultra fast optical communication. This is something some approaches to understanding the biological motor system using robot technologies. This is a visualization of the EM radiations leakage for the hardware security. There are more activities from the facilities controlling the magnetic state with electric fields. Stochastic computing system based on the brainware LSI, and some new small mini wave. Sorry, I cannot read that. Okay, what I want to say is a small size millimeter wave wireless terminal for the HDTV systems. Now I'd like to talk a bit about records of our institute. The left panel shows the number of the people, 65 faculty members, and about 70 administrative staff, and also over 200 students. This year we have 360 in total as a member of our institute. This right panel shows the budget condition. Green one is the budget from the government for the operation, and the orange one is the budget from extra fund. The percentage of the extra fund budget is about 40%. The number is not bad and good enough to operate our institute in a good condition. But we wish to make the percentage at least to the 50% so that we could compensate the continuous reduction of the budget from the government in future. So that is one of our issue to address. Okay, this slide shows the international academic exchange agreements. The left one is a university level agreement where our institutes contribute. The term with main, meaning we are in the main layer of the agreement. Just from USA, Europe, and Asian countries. Similarly, we have the organization level agreement, meaning our institute and some organization in our university in the world. Also, we have agreement with in the university of the Europe, US, and China, Asian universities. So this suggesting that we are pretty much good international relationship. Okay, I'd like to describe two of the projects briefly, which our institute leading with support from the government. First one is the New Paradigm Brainware LSI project. The three pictures here describe the new LSI created in the project. First one is a motion vector detection LSI based on the human visual system. The second one is the brain-inspired LSI using a chaotic neuron, meaning that some circuit using the chaotic computation is mimicking the brain system for the unconscious process. And the third one is the brain-inspired LSI also for the low-level image processing based on the stochastic computing. So stochastic computing is another new idea comparing with the conventional LSI design. Okay, the second one is a research platform for yotta-scale data sciences. Please look at this figure. This figure shows the amount of information that mankind generates within 1 year. This one. That increase acceleratory and that reaches to 1 yotta byte in the year of 2030. 1 yotta is 10 to 24th, the big data. You can compare this line to the green line. That is the total storage capacity we will have in the year of 2030, for example. That is much less than the total amount of information we generate. So we have to choose the information to save, deal with the process or whatever. To do that, we have to choose based on the value of the data. But that is a very difficult question, how to decide the value of information or data. So we are thinking of the detecting or estimating the value estimation of a human or quality estimation of the data of the human, and creating the computer system for data processing to get the similar information. This is interesting because we are working on with other departments like economics or data sciences or so on. All right. The second part of my talk is about the activity as a joint usage research center, meaning the activity of the collaborative research projects. The joint usage research center system started in 2008 by the Ministry of Education, MEX in short, in 2008. The objective of this system is listed here, but in our case, the objective is to conduct collaborative research so that we are doing supporting the collaborative research projects, as many of you are joining. In the field of ICT, of course, these four is a subfield of the area. This slide shows the number of the projects as a function of the years. If you compare the number here, just look at the total number, 146 in this year. That is much larger than the 5 years ago, 2014. That is under 100, about 19. So just keep increasing monotonically. I think we are having more collaborators all over the world. This is the number of the people contributing to the CRP. It's still also increasing the number, of course. This is the type of the project. Just look at the international cooperative research type. The number is 44 this year. So the 44 among 1 out of 146 is less than 1/3, but close to 1/3. So many of the projects are international. So that is very good for our institutes to be global. This is the budget situation. This is the total budget. The red one is support from the government. Some fluctuation up and down. Down is not good news. So we want to try to keep that in this level in future. To do that, we have to make our activity more visible to the government. We have many projects based on the activity of CRP. Yota is one of them, and the spintronics of the another one. That started with type-based, meaning the collaboration with between the organizations. So the people in the Osaka University, Keio University, University of Tokyo, and us started to the project, and now that is supported by the government as a center for spintronics research network. Network means the network among the, all over Japan. Now I'd like to talk about the research I have been involved. That is about cultural and individual differences in color lexicon. This project is with these people, Japanese, American, and Taiwanese, and Thai. Because we are now working on the color lexicon in Japanese, English, Taiwanese, Chinese, and Thai. And we are wishing to increase the number of the countries or languages in future. I'd like to start with a basic idea of color vision, because many of you are not familiar, perhaps. Well, but still, this is a simple one. As you probably know, color vision starts on the retina. There are 3 types of photoreceptors, 3 cones. They have different spectral sensitivities. Long wave sensitive cone, L cone, fitting here. Middle wave sensitive cone, M cone, fitting here, and S cone, fitting here. Because of the differences, we have some information about the wavelengths in addition to the strength of the light. This is a simple model, established model of color vision, 3 cone types. And then there are a second stage that is called opponent process. Black and white opponent signal, red and green opponent signal, yellow and blue opponent signals are processed there. Red and green or luminance signal is made by just adding the outputs of L and M cone. Red and green or subtraction of L and M cone signals. And yellow blue, the subtraction of L plus M and X. These are relatively well established and documented. And many of the color phenomena can be explained by this model, such as the color adaptation. This is a simple demonstration about color, just for fun. Look at somewhere like the tips of this leaf or a file. As most of you have experienced before. You see for example, green circle on a white paper after stirring red circle. The same thing you can see here, but in the real image. So the blue part appear to yellow in the next slide, like this. I think you see vivid color here, but if you move your eyes around the picture, you can see the picture itself is black and white. And if you go back to the initial location, you may still perceive the colors. But simple color adaptation or color after image. So if you go further away from opponent process, things become complicated, and I don't think there's a solid model for color vision. But if you further higher, we know that there is a connection or interaction with the concepts and the perception. The color lexicon is related to here. To show what I mean here, I have a demonstration, another demonstration. There is a task for you. Just do when you see red, raise the right hand. You don't have to do like that, just small action is fine. If you look at the green, just left hand raising, and the other color do nothing. So just practice red, okay, green, okay, brown. Oh no, oh looks so reddish, okay. Well, the accuracy is not a problem here, but please act as quick as possible. Ready, go. Okay, I think you got the idea what I mean by the interaction between concepts and the color perception. We know that responding to color of ink, meaning the color of the ink, red here, red, green, the words influence. If the color of ink and the color word is consistent, we can respond faster comparing the inconsistent cases of this. This is called Stroop effect. So color and the color terms are related, of course, and the brain has some interaction somewhere. There are long history of color lexicon. For example, Berlin and Kay found that color categories are more or less the same across world, regardless of language and cultural differences. They say that there are basic colors, perhaps 11. Red, green, blue, yellow, purple, orange, pink, brown, white, gray, black in English, and the corresponding colors are written here in Japanese. Of course, some languages has less number of color terms than 11, but all of them uses one of them. Like if there are only 3 colors in a language, that is, for example, white, black, and red one, something like that. If you look at the color samples or color tips like this, you can discriminate the colors, adjacent colors here and here, or the condition might be very good, but perhaps you can do that. But if you are asked to name the color name region becomes something like this. Green this area, blue this area, orange this area, here that area, or something like that. The question is how the region of the color named in a particular color differs or similar among the different languages. The Lindsay and Brown, they are also our contributor, found that even within the language, in their case English, there are some subtypes of the colors. They call that the motif. Some of the people, 37 or 51 subjects, use color category like this, but other people use this one. The difference is here. They call that the people have a green-blue motif shows something like this, and the people with green-blue and teal motif use something like this. So there is a difference between these. These individual differences may be corresponding to the individual differences between the different languages. That is the question we want to ask. Well, just skip this one. Skip this one. I'd like to show a bit about Japanese and the Taiwanese data here. And the experiment we did is something like this. Using color samples like this and showing one by one to ask the subject to name the color with a simple and using a single and monolexemic color term, so that they are not allowed to use compound colors like yellow, green, or modifier words like pale, purple. That is a rule. This shows how many colors are used for each subject. Many of them used 16 and some used about 50. So individual variations there. And we analyzed the data, as in the case of English, of the Lindsay and Brown. We found also two different motifs. The differences again here, blue-green region. One type shows a large mizu, water color here. The other is a smaller region for that. It is interesting to know the difference of the motifs, the same area between English and Japanese, although the English case, the tail is around here, so it's not the same. Interesting finding, another interesting finding is about mizu. This is worked also in 30 years ago by Ichikawa and Boynton. Ichikawa is also our collaborator. They decided, concluded that mizu is not the basic color because the large overlap is owl. But our data shows the less overlap, similarly overlap between pink and red, so we can call that the basic color. So we concluded that mizu has become a basic color since then, after 30 years. That kind of change seems to be happening. I think I should stop. You can see some other data from Thai in a poster session. Professor Rumi Tokunanga will present that. Thank you very much.